Hello, let us discuss the part 2 of cholesterol metabolism. Sangeeta here. So, in this session, we'll be discussing the metabolic fates of cholesterol, or we can discuss the important compounds synthesized from cholesterol. Cholesterol has multiple metabolic fates, and we know most of the cholesterol biosynthesis, which mainly occurs in liver. So inside the liver, what will happen? From the newly synthesized cholesterol, a portion or small fraction of the cholesterol will be utilizing for the synthesis of hepatocytic membrane itself, or which will be incorporated into the membranes of liver hepatocytes. And in other tissues, cholesterol is converted into mainly steroid hormones, mainly in the adrenal cortex and gonads, and vitamin D, which is synthesized in liver and kidney mainly, because the activation of hydroxylation of vitamin D, which is mainly occurs in liver and kidney, and also this is utilized for the extrahepatic cholesterol will be utilized for the synthesis of bile acid. So most of the cholesterol which is exported in mainly in the form of either bile acid or biliary cholesterol or cholesterol esters. Okay, so let us see in detail regarding the metabolic fate of cholesterol. So first of all, let us focus on the formation of bile acids. So bile acid actually one of the three forms of cholesterol exports from liver, which is a principal component of the bile. What is bile? Actually, it is a fluid stored in the gallbladder and usually excreted into the small intestine and mainly help for the digestion and absorption of the fat containing meal, or mainly help for the digestion of the fatty food or fat containing meals. Okay. Now, regarding the bile acid, the primary bile acids are cholic acid and chenodeoxycholic acid, mainly synthesized in the liver from cholesterol by multi-step pathways. So bile acid synthesis, which consists of mainly 7 reactions. You can see first one, hydroxylation. Second one, chain cleavage, that is removal of 3 carbon fragment from the hydrocarbon chain attached to the C17. Then reduction of the bearing of the steroid nucleus, then oxidation of the terminal carbon of the hydrocarbon chain to the carboxyl group, then conjugation with the glycine, secretion into intestinal canal, deconjugation, and finally deconjugation and removal of hydroxyl groups. Okay, now let us discuss the steps in detail. The first step is that the hydroxylation of cholesterol. So this hydroxylation of cholesterol occurs by a microsomal enzyme that is known as 7-alpha hydroxylase enzyme, which help for the hydroxylation of cholesterol to 7-hydroxycholesterol. An additional hydroxyl group present in the 7th carbon atom of the cholesterol molecule. And remember, this 7-alpha hydroxylase enzyme is a microsomal enzyme which requires molecular oxygen and NADPH as the coenzyme, and also cytochrome P450 enzymes. Okay, so from 7-hydroxycholesterol, with the help of several reactions or several steps, it leads to the synthesis of primary bile acids as cholic acid and chenodeoxycholic acid. Okay, so this involves the multiple steps like chain cleavage, removal of the extra carbon atom from the 17 carbon atom, then reduction of the bearing of the nucleus, then oxidation of the terminal carbon atom of the hydrocarbon chain, etc., etc. So multiple enzymatic reactions. In previous slide I have discussed all those reactions. The first 4 reactions are the multiple reactions which they meant here, and this 7-hydroxycholesterol undergoing these many steps, that is chain cleavage, reduction of the bearing, oxidation of the terminal carbon, etc., etc., and leads to the synthesis of the primary bile acids as cholic acid and chenodeoxycholic acid. Okay, now before the bile acid leave the liver, what will happen? These primary bile acids will conjugate with either glycine or taurine. Both the primary bile acids undergoing conjugation with the glycine or taurine and to form the conjugated bile acids as what? Glycocholic acid or glycokenodeoxycholic acid or taurocholic acid or taurochenodeoxycholic acid. Okay, so these are known as actually bile salts. So in alkaline bile, the bile acid and their conjugates. Conjugates means this glycocholate, taurocholate and glycokenodeoxycholate and taurochenodioxycholate. These are the conjugates of bile acid. And in alkaline condition, what will happen? These bile acid and its conjugate assumed to be, which is present in the form of salt. That is why the term comes as bile salts. Okay, now this primary bile acids further metabolized in the intestine. The next reaction which occurs in the conjugated bile acid, what will happen? Which is secreted into the intestinal canal. That is the sixth step of bile acid, where what will happen? This is metabolized in the intestine by the activity of intestinal bacteria and producing the secondary bile acid as deoxycholic acid and lithocholic acid. Remember, this deoxycholic acid and lithocholic acid are the secondary bile acid which is synthesized in the intestine after the release from the liver to the intestine through the bile duct along with the bile. Okay, so what are the primary bile acids? Cholic acid and chenodeoxycholic acid, which occurs in liver itself with the multiple enzymatic reaction. Further, which undergoing conjugation with glycine or taurine in liver itself to form the conjugated form of bile acid. So both bile acids and conjugated form of bile acid in the alkaline condition together, that is known as bile salts. Okay, and further which is secreted in the intestine, where intestinal bacteria producing the secondary bile acid as deoxycholic acid and lithocholic acid. Okay, and one more terminology. So this is all about the synthesis of bile acids. Okay, so primary bile acids conjugated with glycine taurine to form that and all I have already discussed: glycocholate, taurocholate, glycokenodeoxycholate, taurochenodioxycholate. These are the conjugated bile acids. Now, enterohepatic circulation. The conjugated bile salts are synthesized in liver and accumulated in the gallbladder. From gallbladder, they are secreted into small intestine where they are served as emulsifying agents for the digestion and absorption of fat, and here the secondary bile acid synthesis occurs. And what is the meaning of enterohepatic circulation? Here, a large portion of the bile salts are reabsorbed and returned to the liver through the portal vein. That is the meaning of enterohepatic circulation. You can see a majority of the bile salt which secreted or synthesized in the intestine reabsorbed to the and returned back to the liver through the portal vein, that is enterohepatic circulation. So the bile acids are recycled and reused several times in a day. Okay, so this is known as enterohepatic circulation. The fecal excretion of bile salts is the only route for the excretion of cholesterol from the body. Okay, this figure which explain regarding the bile acid synthesis and excretion together in one figure. Or everything I have already explained. You can see from cholesterol, primary bile acid synthesized, then conjugation occurs, then in intestine, secondary bile acid, primary and secondary bile salts will secreted to the intestine. In intestine, by the intestinal bacteria, secondary bile acids produced. Some portion of it through the portal vein entered to the liver, that is known as enterohepatic circulation, and some portion will be excreted through the feces. The form of primary and secondary bile salts and bile acids. So this is all about bile acid synthesis. Now the clinical application of bile acid synthesis, that is cholelithiasis. that is gallbladder stone. Bile salts and phospholipids are responsible for keeping the cholesterol in bile in the soluble state. But due to their deficiency of bile salt and phospholipids can lead to the accumulation of cholesterol, and it can develop in the form of cholesterol crystals in the gallbladder. This condition is known as cholelithiasis or gallbladder stone. Patients with cholelithiasis are response to the administration of bile acid, that is chenodeoxycholic acid, known as chenodiol, because bile acid deficiency leads to the crystallization of cholesterol and the formation of this lithiasis, cholelithiasis. Surgical removal of gallbladder is the only remedy. Now regarding synthesis of steroid hormones. Sorry, before that I forgot to mention the importance of bile acids. So you should write regarding the importance of bile acids also. So bile acid mainly help for the emulsification of the digested lipids and facilitate the enzymatic digestion and absorption of dietary lipids. And remember, bile acid production is the only important catabolic pathway for cholesterol. Otherwise, the steroid nucleus of cholesterol cannot be broken down. So the continuous conversion of cholesterol into bile acid in the liver prevents the body from becoming overloaded with the cholesterol. Okay, so it is an important point. Bile acid production is the only important catabolic pathway of cholesterol. So by synthesizing bile from the cholesterol, the body helps to prevent the cholesterol accumulation in the human body. And I told, as a steroidal nucleus, it cannot be degraded in the body. The excretion of bile salts serve as the only major route for the removal of the steroid nucleus from the body. So in textbook it is there what are the functions of bile acids. Bile acids and bile salts are always asked in university examination. Okay, now coming to the second point, that is regarding the synthesis of steroid hormones. Steroid hormones synthesized mainly in the adrenal cortex and gonads. Okay, so examples are given here. Glucocorticoids and mineralocorticoids. These are known as cortisol, and also aldosterone are hormones synthesized in the adrenal cortex or adrenal gland, or mainly in the adrenal cortex and medulla, and mainly helps to regulate the metabolism of biomolecules. Specifically, glucocorticoids regulate the glucose metabolism, and also mainly helps to maintain the water and salt balance in the human body. Okay, and also it helps for the synthesis of sex hormones like progesterones, androgen and estrogen. So testosterone is a male hormone or male sex hormone produced by the testes. Then estradiol or estrogen is the female sex hormone produced in the ovaries and placenta. Okay, so this is regarding the synthesis of steroid hormone, where cholesterol acting as a precursor for the synthesis of all these 5 classes of steroid hormones. So I have not included the structural difference between all these things. So in textbook, all of you please go through with the structure of cholesterol, structure of bile acids, and structure of these steroid hormones. The structural difference, the difference between the number of carbon atom and other side chains being as shown in the textbook. So all of you please watch the figure in the textbook. And next important product synthesized from cholesterol or another metabolic fate is that the cholesterol can be utilized for the synthesis of vitamin D. In vitamin D, while learning the vitamin D, we have understood how the vitamin D is synthesized in human body. It is from the precursor 7-dehydrocholesterol. 7-dehydrocholesterol is a derivative of cholesterol, and that is the intermediate of biosynthetic pathway of cholesterol. So this 7-dehydrocholesterol, which is present in the skin, when it is exposed to the ultraviolet light, what will happen? It undergoing the various enzymatic reaction and the synthesis of cholecalciferol or vitamin D3. Okay, and this vitamin D3, we know that, which is the main hormone which help for the regulation of calcium and phosphate metabolism. All of you please watch the vitamin D synthesis, or observe the vitamin D synthesis from the textbook, how the vitamin D is synthesized from the cholesterol. And remember, the activation or hydroxylation of vitamin D occurs in the liver and kidney cells. Okay, now regarding the transport of cholesterol. Cholesterol is present in the plasma lipoproteins in two forms, either as cholesterol esters, that is cholesterol esterified with the long chain fatty acid. So majority of the cholesterol is transported in the form of cholesterol esters. And nearly less percentage, 25 to 30%, are free form. This may exchange with a different form of lipoprotein. So regarding the cholesterol esters, it is mainly formed in the liver by the action of a specific enzyme ACAT, that is acyl coenzyme A cholesterol acyl transferase enzyme, and this which catalyzes the formation or transfer of fatty acid from coenzyme A, that is fatty acyl coenzyme A, to the hydroxy group of cholesterol and forming cholesterol esters. And once the cholesterol ester is formed, which is being more hydrophobic form and preventing it from entering into the liver membranes. The entry of extra amount of cholesterol to the membrane is prevented by the formation of cholesterol esters. And cholesterol esters are transported through lipoprotein particles to the other tissues, and that use cholesterol where it can be stored in the liver and in lipid droplets. Okay, now in detail regarding the transport of cholesterol, which explaining in this figure, you can see cholesterol is transported in body fluids from the form of lipoprotein particles. Okay, so here you can see cholesterol esters that are resynthesized in the mucosal cells. Okay, so the dietary cholesterol which will be transported in the form of chylomicrons. Okay, so in the intestinal mucosa together with the unesterified cholesterol which will be incorporated into chylomicron, which is a transport form of cholesterol from the intestine and other dietary lipids from the intestine to the blood. You can see chylomicron is a transport form of cholesterol to the liver cells for the metabolism. Okay, and next is that which we are explaining, that uh, the biosynthetically synthesized or de novo synthesized cholesterol which is available in the liver itself. So total the dietary cholesterol and the de novo synthesized cholesterol which contributing the free cholesterol pool in the liver. So liver is a major site of cholesterol synthesis, we know. Here what will happen, the cholesterol in excess of the liver's own need will be transported or exported out into the blood in the form of VLDL. Okay, so liver synthesis occurs there already, and also it taken from the dietary lipid, and the liver will be utilizing a little amount of cholesterol for the synthesis of hepatocytic membrane, and the extra amount will be exported into blood in the form of VLDL. Now this VLDL, triacylglycerol of VLDL are hydrolyzed by the action of another enzyme lipoprotein lipase and form the VLDL remnants, and which are rich in cholesterol esters, and this leads to the synthesis of IDL and LDL. Okay, and the fate of LDL is that LDL is actually major carrier of cholesterol in blood, and the role of LDL is to transfer the cholesterol to the peripheral tissue. These are the extrahepatic tissues. Okay, and next is that regarding the HDL. From peripheral tissues, the HDL picks up the cholesterol from the peripheral tissues and from the other lipoproteins, that is other LDL and all, and converts into cholesterol esters by a specific enzyme LCAT, that is LCAT is lecithin cholesterol acyl transferase enzyme, and these HDL cholesterol esters are ultimately returned back to the liver. Okay, returned back to the liver, and which can be metabolized or degraded or excreted in the form of bile salt or bile acids. Okay, this is this figure which explaining the transport of cholesterol. Okay, now this figure which explains the major sources of liver cholesterol and its utilization, what all we have discussed, and the summary given here. Nearly 500 milligram per day which we are obtaining from the dietary food as the dietary cholesterol. Then nearly 500 mg per day can be synthesized through the de novo synthesis of cholesterol in liver. Total 1000 milligram, that is 1 milligram cholesterol can be available in the liver cells, or synthesized total 1 milligram can be available. And also cholesterol from the extrahepatic tissues or variables in the form of transport of cholesterol from the HDL. Then these cholesterol pool from the liver can be utilized by various route, either from the or it can be degraded in the form of bile acid and bile salt, that is nearly 250 milligram, which can be excreted through the feces, and some part will be utilized for the enterohepatic circulation. And cholesterol lost in bile nearly 500 mg per day. Then also little amount will be converted in the form of lipoproteins. This is regarding lipid profile in normal range. The normal ranges of total cholesterol, LDL, HDL, these will be discussed in detail in atherosclerosis chapter also. But still, the normal level of total cholesterol in body should be less than 200 mg per deciliter. And LDL level should be less than 123 mg per deciliter, and HDL should be between 35 to 60 milligram per deciliter. The high amount of cholesterol, HDL, LDL, etc. are a risk factor for the atherosclerosis and myocardial infarction and other diseases. Now regarding the clinical significance of cholesterol metabolism. The terminology hypercholesterolemia and hypocholesterolemia. Hypercholesterolemia is the increased cholesterol level in blood is known as hypercholesterolemia. The causes for hypercholesterolemia are certain diseases can be used to hypercholesterolemia. For example, diabetes mellitus. In diabetes mellitus, due to decrease in insulin, there will be more lipolysis, increased lipolysis because of the action of glucagon. So that leads to more free fatty acid level. More free fatty acid can lead to increased acetyl coenzyme. The acetyl coenzyme has multiple fate. Either it can be channeled to the formation of ketone bodies, or it can be even utilized for the cholesterol synthesis. Being a precursor for cholesterol synthesis, increased acetyl coenzyme can be even channeled to the cholesterol level. So that is the reason for hypercholesterolemia in diabetes mellitus. Then regarding hypothyroidism as a cause of hypercholesterolemia. Thyroid hormones, that is T3 and T4, induces the transcription of 7-alpha hydroxylase. 7-alpha hydroxylase, which is a key enzyme of bile acid synthesis. So in patients with hypothyroidism, plasma cholesterol tends to rise. Why? Because the activity of 7-alpha hydroxylase will be decreased with hypothyroidism patient because of the decreased availability of T3 and T4. So cholesterol will not be converted into bile acid and bile salts, so there can be accumulation of cholesterol. Then another cause, obstructive jaundice. Obstructive jaundice, where there would be obstruction in the bile duct because of that, due to decreased excretion of cholesterol through the bile. Next cause is familial hypercholesterolemia. That is a genetic disease caused by deficiency or malfunction of LDL receptors. Because of that, cholesterol will be accumulated in the extrahepatic tissues. Another cause is nephrotic syndrome. Nephrotic syndrome is a condition where the permeability of the glomerular membrane is getting affected and smaller molecular weight proteins excreted to the urine because of the leakage in the glomerular membrane. So, being a low molecular weight substance, albumin, compared to the other plasma protein, albumin will start excreting through the urine. So, what will happen as a compensatory mechanism? There will be increase in globulins, including lipoproteins. Because of that, there can be increase in LDL cholesterol. Then control of hypercholesterolemia. It is through consumption of PUFA. PUFA mainly help for the esterification of cholesterol. Then dietary cholesterol. Then dietary fiber control. We should take more amount of fiber which enhances the esterification of cholesterol and excretion. Then we should avoid high carbohydrate because high carbohydrate can be converted into fat. Then impact lifestyle should be there. Then moderate consumption of alcohol and use of hypocholestrolemia drugs. Another terminology, hypocholesterolemia. This is usually seen in hyperthyroidism, then pernicious anemia, malabsorption syndrome, and in hemolytic jaundice. Okay, so this is all about cholesterol metabolism. In second part, we have discussed in detail regarding the metabolic fate of cholesterol, and we have seen the synthesis of bile acid, then other products like vitamin D, steroid, etc. Here you have to study in detail about the bile acid synthesis and how it is getting regulated and what are the functions of bile acid, etc. Okay, thank you so much.